So this is the lesson for section 3.2, which is based on solving equations which have both like terms and parentheses. So we did these separately in the previous chapter, but now we're going to combine them to solve a little more complex problem. So example 1 is writing and solving an equation. So here's the word problem. You are giving a birthday party. For the party, you want to buy a personalized birthday banner that costs $17. You also want to get foil balloons that cost $1.90 each and packs of streamers which cost $1.10 each. You have a total budget of $35. If you're buying equal numbers of foil balloons and packs of streamers, how many can you afford to buy? So start off by figuring out what variable you want to use and writing a verbal model. So let's let n equal this, the number of foil balloons and packs of streamers you're going to buy. Then let $1.90 times n, because each pack of foil balloons costs $1.90, represent the number of balloons, and 110n equal the cost of n packs of streamers. So in this case, we can write our verbal model as the cost of balloons plus the cost of streamers plus the cost of the band equals the total budget. So then we can just plug numbers in for these to write our equation. So $1.90 times n is going to be our balloons, plus $1.10 times n is going to be the packs of streamers, plus $17 for the total cost of the banner equals $35, which is our total budget. Now we can start combining the like terms. We have two terms here that we can combine, and we can also move this to the other side and combine it with 35. So first, $1.90n plus 1.1n equals 3n. Then we can subtract 17 from both sides. To get the 3n alone, which then is going to be 3n equals 18. We can divide each side by 3 to get n, which is n equals 6. But what does this n mean? The n means that you can afford to buy 6 foil balloons and 6 packs of streamers with your budget. So that's the first problem. I'd like you to try this one on your own using similar steps. Remember, you can go backwards and re-look at the previous problem. So you have $15.50 spent on party food. Gumdrops are $3 per pound. Yogurt-covered peanuts are $2.50 per pound. And cashews are $4.50 per pound. If you buy a half a pound of gumdrops, an equal weight of the yogurt-covered peanuts and cashews, how much can you afford to buy? So try this on your own. The next example here, I should have covered some of it up, but is solving equations using the distributive property. So focusing here initially, what we need to do is we need to distribute this -8 to the inside of the parentheses, because it's -8 times everything within these parentheses. So -8 times 5 is -40. -8 times -7c is 56. So be careful here. We have a negative here and a negative here, so it becomes positive. Then we want to get rid of this -40 first, because it's further dissociated from the c, or from the 56c. So plus 40 to each side. Then we can simplify, so you get 56c equals 224. But we want the c alone. That's the goal. So divide both sides by 56 to get c equals 4. Remember, you can also go back and check this. So now plug 4 in here for c, and make sure you still get 184 on both sides. So try these examples below using the like terms after you distribute. Always distribute first. You can't combine 2 and 7 before you distribute to both, because you don't want to forget this part. So always distribute first, then combine the like terms. Example 3 from this section is about combining like terms after distributing. So what I was just saying, combine those like terms after distributing. So in this, here's our problem, which is 3x minus x plus 7 equals 29. We want to rewrite it as an addition problem, especially when you have a minus right before those parentheses. So we can rewrite this as 13. Oops, and I made a mistake here. I forgot to type in this little x here, so we're going to add that in now so we don't forget it. So 13x plus negative 1 times x plus 7 equals 29. Then we can do the distributive property. So I forgot to type my x twice. I'm sorry. So this is a mistake that you may make too, so make sure you're checking. So now we have negative 1x plus negative 7. We can combine our like terms. So 13x minus 1x, or plus negative 1x, is 12x. We want to get rid of that minus 7, so we can add it to both sides to cancel it out here, leaving us only with our 12x equals 36. We can then divide both sides by 12 and get our answer, x equals 3. Again, go back to the original problem, plug this x in for the 3 in for x, and make sure that it's correct. So try some practice problems here and bring them with you to class tomorrow. Remember, first, use the distributive property, then combine the like terms. And that's it for this lesson.